Hello, welcome students for the online lecture on fluid power systems. We are discussing module 2, that is pumps and actuators. So in last sessions we have discussed about gear pump, vane pump, piston pumps, various types of piston pumps, fixed displacement type or fixed discharge type and variable discharge type. So today we'll see two more types of gear pumps, that is internal gear pumps. So if you see the parts of the internal gear pump, there is an internal gear or rotor, drive gear is there, inlet port, outlet port, casing, crescent. So in the internal gear pump, the meshing of teeth of the gears takes place internally and hence the name internal gear pump. This consists of an external gear that meshes with the teeth of the annular gear. Annular gear having internal teeth on inner surface of its circumference. This consists of an external gear that meshes with the teeth of annular gear, which is having internal teeth. The pumping chamber is formed between the gear teeth. A crescent seal is machined into the space between the inlet and outlet or meshing and unmeshing region of the gears, where the clearance between the teeth of the annular wheel and external gear is maximum. In this way, the two inlet and outlet ports are separated, while the oil is carried by the gear past the seal. Internal gear pumps are also available in single and multiple configuration. Low pressure oil from the inlet port is converted into high pressure oil and sent through the outlet port as follows. The internal gear drives the external gear and affects a tight seal where the teeth are meshing. Rotation of the gears causes unmeshing near the inlet port. The cavity volume increases and suction occurs. So here also, as unmeshing is take place, volume goes on increasing and suction is going to take place. Oil is trapped within the internal and external gears teeth on either side of the crescent seal and is carried out and carried to the outlet cavity of the pump. Meshing of the gear teeth reduces the volume in the high pressure cavity near the outlet port. Gerotor pump. Here also there is a gear rotor, casing, gerotor element, inlet port and discharge port. One of the most common types of internal gear pump is Gerotor pump. A Gerotor pump combines an internal gear inside and external gear as shown in figure without crescent seal. In this case, the inner gear has one tooth less than external gear. In this case, the inner gear has one tooth less than the external gear and is keys to the drying shaft. As the gear rotates, each tooth of the inner gear is in constant mesh with the teeth of annular, that is inner teeth gear. As the gear rotates, each tooth of the inner gear is in constant mesh with the teeth of annular. As the annular has one teeth more than the inner gear, it rotates at a slower speed. As the annular has one teeth more than the inner gear, it rotates at a lower speed. Space between the rotating teeth increases. Space between the rotating teeth increases during the first half, that is increasing from smaller to larger volume, drawing fluid into the chamber. Similarly, the space between the rotating teeth decreases during the second half, that is decreasing from larger volume to smaller volume, forcing the fluid into the outlet port. The discharge in a gear pump is a function of external and internal diameters of the gear, width of the teeth, and the speed of the pump. The housing and the core plates or pressure plates are manufactured to the design dimension. Hence, at no time for a given gear pump, it is possible to change the elements of different dimensions. Thus, the displacement of given gear pump remains fixed. The only possibility of varying the displacement is by varying the speed of the pump. Next, we will see the another components which are used in the hydraulic systems. So pumps, already we have discussed different types of pumps which are used to pump the oil in the system. So in hydraulic system we are going to use the positive displacement pump. So now let us see one more different component that is known as accumulator. So this is also one component which is used in the hydraulic system. A hydraulic accumulator is a device that stores the potential energy of an incompressible fluid. A hydraulic accumulator is a device that stores the potential energy. It is going to store the potential energy of an incompressible fluid held under pressure by an external source. The stored potential energy in the accumulator is a quick second source of fluid capable of doing useful work. The stored potential energy in the accumulator is a quick secondary source of fluid power capable of doing useful work. So different types of accumulators are weight loaded or gravity accumulator, spring loaded accumulator, gas loaded accumulator, non-separator type, separator type. In separator type there is piston type, diaphragm type and bladder type. So this is spring accumulator with a spring. So you can see in the figure a symbols of reservoir, filter, pump. After pump there is check valve, and after check valve we are going to fit the accumulator, and the same pipeline it will continue towards the direction control valve and to the actuator. So pressure is equal to spring force divided by piston area. Pressure is equal to spring force divided by piston area. So force divided by area is nothing but it is the pressure. Spring, we can see the ram which is moving inside the cylinder. The port of the accumulator is connected to the pipeline of the system, and we can see the symbol of the accumulator, spring loaded accumulator. So when you start the pump, the oil which is pumped by the pump, it will flow towards the check valve, and check valve will open and the oil move towards the actuator. So before actuator there is accumulator, so accumulator will be charged. So high pressure oil will enter the accumulator. As oil enters the accumulator, the piston ram is going to move up and the spring is compressed. Spring is going to compress. So this is accumulator. So just imagine when there is a power failure, the work which is done by the accumulator will not stop. To complete the work by the accumulator, the oil will flow from the accumulator to complete that remaining work. So it means accumulator will store the energy in it, potential energy. So that can be used when there is a power failure or when there is a pump failure. So when there is a power failure, the spring inside the accumulator starts to expand, and the oil which is moving out from the accumulator, it will move towards the actuator to complete the remaining work of the actuator. So even when there is a pump failure or power failure, the work will not stop by the actuator. It will be completed by using the energy which is stored in the accumulator. So this is spring loaded accumulator. So this is deadweight type accumulator. So on the accumulator there are the dead weights as the pressure required by the system. According to that we are going to increase the weights on the accumulator, dead weights on the accumulator. So here also ram is there inside the cylinder. Dead weights platform is there which is connected to the ram. So it is connected in the line with the system. Accumulators are fitted in line with the system. So here we can see again reservoir is there, filter is there, pump is there. Pump discharge is moving towards the accumulator and actuator. To system means it is towards the actuator. So now when you start the pump, the accumulator is going to be charged and it will store the energy in it. So when you start the pump, the oil will flow in the system and it will enter the accumulator and the ram will move up along with the dead weights, and afterwards when it is charged the oil is moving towards the actuator to come do the work. So now the accumulator is charged. So when the energy is going to used means when there is a power failure. When there is a power failure or pump failure, to complete the work by the actuator, the oil is moving from the accumulator. At that time piston will starts to move down and the oil is pushed outside and the oil will flow towards the actuator to complete the remaining work. So it means the accumulators will act as a stored energy in the system. They will store the energy. That energy can be used when there is a power failure or pump failure, and it will complete the work in the actuator. So this is deadweight accumulator. So according to the pressure required we can vary the dead weights on the accumulator. The symbol is shown. So this is the circuit diagram where we are going to use this accumulator in the circuit. So all the components here we have shown by the symbols. So tank, that is the reservoir, that is a symbol for reservoir. Next there is a symbol for filter. Next symbol of pump. Next symbol of pressure relief valve. Next is the symbol of accumulator. Next is symbol of direction control valve, 4/2 direction control valve. After direction control valve there is a actuator, a linear actuator on which load is acting. So accumulator is fitted in the line. So when there is a power failure, when the pump stops the pumping the oil from the accumulator move towards the actuator passing through the direction control valve to complete the work. Separator type accumulator. So in cylinder you can see a piston which separates oil and gas. So when you start the pump, oil is filled inside the accumulator. So already initially the gas is filled in the accumulator using this gas valve. So but when you start the system pumps, the oil will flow towards the accumulator and it will occupy the space in the accumulator and the piston is moved up, means the gas which is compressed there. So when there is a power failure or pump failure, the gas will start to expand and the oil will move to the oil which is coming out of the accumulator, it will move towards the actuator to complete the work. So this is separator type accumulator. So here oil and gas are separated by piston. So this is non-separator accumulator. So oil and gas are in contact with each other. They are not separated. They are in contact with each other. Oil is in contact with the gas. So here also to charge the first, the gas is filled in the accumulator. So that accumulator is fitted to the system. So when you start the system, the oil will start to enter the accumulator and the gas is compressed. So same here also, when the gas is going to expand means when there is a power failure or pump failure, at that time gas will expand, oil will move towards the actuator from the accumulator to complete the remaining work. Diaphragm type accumulator. So here you can see the diaphragm. So in this type of accumulator also, it is first filled with the gas. So by using this gas valve, we are going to fill the gas inside the accumulator. So at that time, shut off valve position will come down. So when you start the system, the oil will start to enter the accumulator and the diaphragm will move upwards, and the gas which is inside the accumulator, it will start to compress, and working is same. So when there is power failure, the gas which is filled in the accumulator starts to expand, and the oil will start to move outwards towards the actuator to complete the work. This is bladder type accumulator. So first in the bladder we are going to fill the gas, and when you start the pump in the system, it is charged with the oil, and the gas inside the bladder is compressed. So these are the different types of accumulators which are used in the hydraulic system. So the function of the accumulator is to act as a power source. When there is a power failure, it will act as an emergency power source for the retraction of the cylinder. It will act as a shock absorber, and the accumulators will act as a leakage compensator. So if there are leakages, external leakages in the system, due to that the oil pressure will decrease. To keep the correct pressure, the oil is coming from the accumulator, so it will act as a leakage compensator also. It will act as a shock absorber, it will act as an emergency power source, it will act as a power source. So remaining things we will discuss in the next class. Thank you.